I'm the project manager. My name is Victor Tran. This guy right here, this is the top SolidWorks guy of the whole entire class. What is your name?
Michael Sullivan.
All three guys right here, these are the best coders in the classroom. Who do we have here?
Ashton St. Michael.
Will Hadigan.
And
Michael Villasek.
So our group was introduced with a challenge where we had to design an end effector for the CNC machine so that we could pick up 8 different blocks and stack them accordingly. We do have possible time constraints. We also have material constraints. We also have the ability of the actual CNC machine itself with our own experiences. Speaking of experiences, we have our own issues with our own experiences with SolidWorks, with MATLAB. So we're simply just beginners with this whole engineering design process. So understanding this problem, we have to figure out a solution. And our solution first was understanding what we need to do, how we meet our constraints, and how we can establish a plan according to those constraints. So our plan was to make sure, again, we take into account our time constraint, our limited materials, our overall experiences, and again, the ability of the CNC machine. We also have to adhere to each member's skill sets as we introduce ourselves in the beginning. Sully, Ashton, Michael, and Will, everybody has their own talents. We have to adhere to them and maximize them during this project. We designed our plan based off of the engineering design process, making sure that we satisfy research, making sure that we satisfy some time brainstorming, and making sure that we have some time extra so that if there is any failure, we can still come back and revise our project. We also have to have everything organized out, obviously, making sure that we're timely and meeting our time constraint and our due date and our deadline. So for our solutions, our main focus was making sure that we understood what we were looking for. And we had to research these different designs and take different elements and add them together in our own way. And what we tried to focus on was making sure that we had 5 different grippers that we can select from when we make the decision on which one's the best gripper. What we were mainly looking for was precision, reliability, versatility, and durability, making sure that it is one whole piece and it doesn't fall apart as the CNC machine is moving.
So for our constraints in general, we had a constraint of 1 month, 4 weeks, or 4 lab periods per week. We also didn't have a large selection of materials to choose from, which consisted of acrylic, cardboard, and wood. We also had problems with the CNC machines itself because they either did not work or were very old and we could use them about 3 times per lab. We also lacked experience, so during those 4 weeks we had to learn on the go, and we also had the constraint of our servo motor not being strong enough to turn our gripper, and it had a lack of range of motion.
So this is how our group decided which type of gripper we wanted to go with for our project. We had a list of qualities that were crucial to our decision, such as manufacturability, size, maneuverability, complexity of assembly, gripper strength, and weight. We weighed each gripper on a scale of 1 to 5, and the gear gripper came out on top with an average of 3.4 per quality. We loved how strong the gripper was and its mobility and strength to pick up the block and accurately move it and place it to another spot. So that's how our group ended up choosing the triple gear gripper.
For the gripper, on our previous slide, we said that we picked the 3-gear gripper. And we did research on different kinds of grippers, and we thought that this one would be the best. So we did more research on how to do the gears and how to actually put it together in SolidWorks. So then we came up with 2 grippers on each side, and then we had 3 gears, these 2 big ones and that small one right there. And then we had 6 pins, there's 2 on the top, 4 on the bottom, and 2 base plates stacked on top of each other to give it more density. And then we had a metal bracket, which we didn't end up using for it. We just kind of put it on the CNC machine. And then we had the stability bracket, same thing with the metal bracket. And then the motor, it wasn't really strong enough. We kind of had too heavy of a gripper. The motor wasn't fully strong enough, but we were able to kind of make it work. So besides that, we just attached that onto that black gear right there. And then everything worked out good. And design worked pretty good.
So we did not necessarily plan for this. We were very confident in our team. Our guys are top of the class, of course. That's why we're all together in one group. However, we understand that the engineering design process has to have time for revisions and betterment. One of our problems was our code wasn't working properly, so we needed time to make sure that we refine the code and develop the code in the right way. Our second issue was our SolidWorks design. We had many issues about our SolidWorks design, the way it was reading through Adobe and laser cutting. There was many issues. However, at the end of it, us as a team, we were able to work together, delegate the work properly, and were able to overcome all of the challenges that we were faced with.
So the biggest problems with our code was that we spent about 2 labs with a malfunctioning CNC machine, where our code would basically replay the same code in a different set of functions would happen. Because of this, we spent a lot of time going over our code and trying to manually change the code in order for it to work. And eventually it would work sometimes, and it just wasn't reliable. So we came to the solution that we just had to switch to a new CNC machine that worked. Because the machines are old, there was a lot of wiring issues where they weren't really working well, and the servo motors got extremely hot, leading to the shrink wrap to come off mid-set, and then we'd have a major setback. We had to let it cool down. Another problem was the fact that we had to manually reset the CNC machine with our hands, turning it hundreds of times in order to get back to the origin and reset our code. Once we switched to a new CNC machine, the coordinates were off. I don't know why, but we had to fix that issue. In order to pick up the block, we had to reset the coordinates where we wanted to go and find a new place to pick up the block.
Okay, so for another problem, we had some problems with SolidWorks. And one big problem we had at the beginning is when creating the actual gripper on SolidWorks, we had a lot of trouble with it being okay with what we're doing, whether the sides were okay. It would tell us that many times something was off, so we had to kind of redesign it in order for SolidWorks to actually like what we were doing and let us do what the design we wanted. And then another problem was that some of the parts were 3D on the gripper, so we had to kind of make 2D versions of the parts and stack it on top of each other in order for it actually to fit the gripper and make the gripper work. And also our first take on it, it was a little bit too small. The holes weren't really big enough for screws to fit inside. So then we had to scale it by 1.75 times the first gripper in order for us to get holes big enough, which also kind of caused a problem because it made it a little bit too heavy when actually trying to use the motor on it. But we were able to slightly do it if we put out the right angle. And then Adobe, sometimes at first we had it as millimeters, which Adobe kept picking it up as inches. So it would be way too big when we actually put into the laser cutting program. It was such a small fix, but we kind of kept going over it because it was just so obvious. And then so once we fixed that, then everything was basically okay. We were able to laser cut everything with acrylic, and then everything worked out. So we attached it to the CNC machine. We got it to move to the block. It picked up the block after we put paper mache on it, so it could help the friction, and it was able to pick it up better. And after that, we were able to pick up the block, move it to where it needed to be, and then bam, done.
So right here we have our initial prototype and our final prototype. We don't want to spoil the final prototype just yet, but our initial prototype was made out of cardboard. We wanted to make sure that the dimensions were correct for the materials we were given. Obviously, one of the material constraints that we had was our screws were either too big, too small, and we wanted to make sure we met that constraint. And we understood that, well, this prototype is too small. And at the end of it, we had to scale factor increase it by 1.75 times the original size. Now here is our final design, as I'll show the video right here. As you can see, our final gripper design was very, very promising. We love the way it looked, we love the strength of it. We even added paper mache and sandpaper grippers at the end of it to make sure that the block would frictionally be picked up. So overall, our prototype, from our initial point to our final point, we are very, very satisfied with the way it ended up.
So using our prototype, we began to run the final test. The code worked very well for the operation of the design, so we were pretty happy.
As he said, as we switched to the CNC machine, the code worked. We solved those problems, and we were able to move the block, move the CNC over to the block, move it down, pick it up, and move it back to the origin to place it back down. And we'll cut to a video of that right here.
So that was a huge gap. Yeah, like you release. So please.
So as you can see, our design works. It could not complete all the orders as provided, but the full intention was still there. We were satisfied, and we were happy with the end product.
So as you can see here, my buddy Sully here, very, very happy about our first prototype. So considering the fact that we're that happy about our first prototype, guess what? We're very, very, very satisfied with our final prototype. However, of course, we weren't able to execute the full 8 cubes, but
We did learn that the engineering design is not perfect and there's always room for improvement, but we are very content with it, and we learned that our constraints weren't effective.
overall, if our constraints weren't a factor within our overall design process, we understood we'd be much, much further, considering the fact that some of our 3D parts were an issue. And if we had the chance to 3D print those parts, we would be in a much, much better position. But overall, we learned a lot during this process. Thank you for watching our presentation. Have a beautiful day.